In this lesson, we'll talk about applications of systems of linear equations into variables. Before we will start solving some word problems, let's go over the general guidelines or hints. Solving word problems is like putting together puzzles. The more you do it, the easier it is. Also, you train your mind to be more observant and find this missing piece more efficiently. How to proceed when we encounter a word problem. The very first thing that I will suggest is to read the problem a few times, at least twice. First time, try to just get the general idea what this problem is about. Second time, try to weed off unnecessary words and just focus on the important information. After we familiarize ourselves with the problem and possibly recognize the type of the problem that we deal with, it's time to organize the data in a useful way. For example, we can draw appropriate tables or diagrams. We can list relevant formulas. The idea is to list all the data that is given in relation to what we already know. Since most of us are visual, try to draw the situation that refers to the problem and place the given data on the diagram as well. Then it's time to assign variables for the unknown quantities, usually for the quantities that the question asks for. Here, a hint from me would be use meaningful letters, so we don't need to use letters like X and Y all the time. For example, if we talk about time, the more meaningful letter would be T rather than X. If we talk about number of people, I would probably suggest N. If we talk about length and width, why don't we use L and W? So we don't have to use X and Y all the time. Then we're usually ready to write equations. Those equations may follow a relevant formula that was, for example, at the top of the table that you used, or any common sense pattern. It could be any geometric equation. For example, if we play with right-angle triangle, keep in mind Pythagorean equation, or any common sense pattern that applies to the problem. After we have the equations, I would say 80% of the problem is already done. What's left to do is to solve the system of equations. And then go back to the question in the problem and check if your answers make sense, if they are reasonable. For example, if you end up with time that is negative, oh, something went wrong. So that would be the red alert to go back and check where's the mistake. Similarly, if you after, for example, number of people going for a trip and your answer end up to be 58.5, well, that's something not quite right. So this is very important to check if the solution makes sense. Finally, we just need to give the formal answer. It can be just a short sentence or even a phrase, but this is another double-checking point if we actually answered what the question asked for. Now we can see some commonly used tables or patterns or formulas that may be helpful in solving various word problems. So the first type will be geometry problems. Here we have an example. A rectangular soccer field has perimeter 360 yards. Its length is 20 yards less than twice the width. What are the dimensions of the field? So after just the first reading, we know that we are talking about geometry problem. It is something about rectangular shape, its perimeter, and we want to find the dimensions. Dimensions means the length and width. Okay, so let's draw a rectangle and introduce the variables. Let L is the length and W is the width. And then we need to start setting up equations that will relate length and width. Since we have two variables unknown, we need to create two equations that will relate them in order to be able to solve. So the first equation will come from the first sentence. Let's read it again. Rectangular soccer field has perimeter 360 yards. Perimeter means the length around the rectangle. So we go twice along the length and twice along the width. 2L plus 2W. This whole perimeter is equal to 360. So that's our first equation. The second equation will come from the second sentence here. its length is 20 yards less than twice the width. So we have some relation between length and width. Since length is means is equal, 20 less than, that's a backward structure. 20 less than means I am going to subtract 20 from something. What's this something? Well, the something is twice its width, so 2 times w. And we have second equation. Okay, let's write it down here so we can clearly see our system of equations. And now we can solve this system using any of the algebraic methods, either substitution or elimination. Since the second equation is already solved for L, the substitution will be more natural here. Let's use substitution. We take the substitution expression and replace L in the first equation by it. Okay, so we have 2 times L. Instead of L, put a bracket, and that's what L is in terms of W, 2W minus 20. Plus, it's very important not to forget this 2W from the original equation. So plus 2W equals 360. And then we have equation in one variable, so we know how to solve it. But let's solve it as efficiently as we can. For example, I could distribute this 2 to the bracket, but I could also divide the whole equation by 2 and make sure that my numbers are smaller. Because each term, that's the first term, that's the second term, that's the third term in our equation, each term is divisible by 2. So yes, we can do it. If I divide by 2 each term, so this 2 will be gone, that 2 will be gone, and this will be divided by 2. Okay, so we'll end up with 2w minus 20 plus the single w equals 180. And now let's collect like terms. 2w plus w is 3w, and we can bring the 20 to the other side. 180 plus 20 would be 200. Okay, so to get w by itself, we need to divide by 3. That will be 200 over 3, which as a mixed number is 66 and 2/3. Okay, but we also need to find the length because we've been asked for both dimensions. So let's take this w, maybe in an improper fraction form because it will be easier to calculate, and plug it in to the substitution equation in order to find what the length is. So length equals 2 times w, but w is 200 over 3. 200 over 3. And then minus 20. So we have a bit of calculations and fractions. 2 times 200 over 3 is 400 over 3, because when we multiply a fraction by a number, the number goes into numerator. And then minus 20. Since I want to combine these two fractions, I want this 20 to have denominator 3, which means instead of 20, I will actually have 60 in the numerator, because 60 over 3 is 20. Okay, and now we are ready to finish. 400 minus 60 is 340 over 3. So finally L equals 340 over 3 is 113 and 1/3. 113 and 1/3. Okay, so we have both dimensions. Now it's time to answer the question. The length of the soccer field is 113 and 1/3 of a yard, and the width is 66 and 2/3 of a yard. Is this answer reasonable? Well, how can we check this? If we add these two numbers, the length and width, which is not so bad because 1/3 plus 2/3 will create 1, and then 113 plus 66, it will be 179 plus another 1 from fractional parts, it will be 180, and 180 is exactly half of 360, so yes, that makes sense. Here we have another type of problems, total value problems. 3 baseball tickets and 2 football tickets cost this much. 2 baseball tickets and 1 football ticket cost that much. What are the ticket prices for the 2 sports? So, since we have 2 sports, we need to introduce 2 variables. Let's use suggestive letters. let B be the price of a baseball ticket, because it starts from B. And let F be the price of the football ticket. Now we're going to use a common sense pattern. To get the total value of the tickets bought, we need to add the value of all baseball tickets and the value of football tickets. Okay, let's try to use the information from the first sentence and convert it into equation according to this pattern. 3 baseball tickets. We have 3 baseball tickets, 3 B's. And 2 football tickets, 2 F's. Costs, that means they are equal to this much. So that's already closer to an equation. Let's try to write this equation. 3 baseball tickets. The value of the 3 baseball tickets is 3 times the price of 1 baseball ticket, plus 2 football tickets. The value of these football tickets is 2 tickets times the price per 1 football ticket, equals 229.90. That's our first equation. Let's do exactly the same with the second sentence. 2 baseball tickets, so 2 B's, and 1 football ticket, 1 F. All together cost this much. Okay, let's write it. 2 baseball tickets plus 1 football ticket, just 1 F, we don't have to write 1, equals 128.27. Fantastic, so we have the system of equations. Now what's left to do is just to solve it. How do we solve it? It's up to us. For example, we could use elimination method. If we wish to eliminate F, we should multiply the second equation by how much? Yes, -2, because we want to have opposite coefficients by F in order to cancel them in the future. Okay, let's rewrite the whole system. So the first equation is 3b plus 2f equals 229.9. I don't need to write this 0, it's just 0.9. And the second equation multiply by -2, so it's -4b, -2f, and then we can use calculator. 2 times 128.27 is 256.54. Okay, now we're ready to add side by side our equations. That will allow us to cancel the f terms, and what we end up with is 3b minus 4b is -1b. On the other side we have -26.64. To add these two numbers you just use calculator, which means that b by itself is 2664. What does 2664 stands for? Oh, let's go back to our let statement. B is the price of the baseball ticket, so 2664 is the price of 1 baseball ticket. Okay, but we need to find the price of the football ticket as well. So what we can do here is to plug in this value for B to one of those equations. For example, let's choose the second equation. We have 2 times 2664 for B plus F equals 128.27. So to find out F, we go 128.27 and we subtract this product. Let's find out how much is that. 2 times 2664 is 53.28. Okay, therefore F equals 74.99 after subtraction. And what does this mean? Well, that means that $74.99 is the price of 1 football ticket. We're ready to give the final answer. A baseball ticket costs, baseball, we're looking at B, $26.64, and the football ticket costs $74.99. And we're done. The next type of problems will be investment problems. Quite often, investment problems will refer to the formula interest equals principal times rate times time. And even simpler, the time is usually 1. So if t is 1, then our formula becomes I equals P times R. So principal times rate, amount of money that we put into the account times the rate that the account is paying. Okay, let's try this example. An executive near retirement made two investments totaling $18,000. In 1 year, this investment yielded $950 in simple interest. That's good to know. It's simple interest, so yes, we refer to this simple interest formula. Part of the money was invested at 4% and the rest at 6%. How much was invested at each rate? Okay, so what do we know here? We have total amount of money $18,000 and we split this money into two accounts. Each of them pays different rate. What the question asks for, how much was invested at each rate? This type of question could be done using just one variable. But since we practice solving systems of equations, let's use two variables. One variable will stand for the amount of money that we put into the account that pays 4%, and the other variable will represent the amount of money put into the account that pays 6%. Okay, let x represent the money invested at 4%, and let y represent the amount of money invested at 6%. When I solve investment problems, I like to visualize what's going on with the money by using this type of arrow diagram. The $18,000 was split into two accounts, so I put two arrows. The first account pays 4%, and if we put X dollars at 4%, the interest that we gain from this account will be calculated according to this formula, particularly principal times rate, because we are talking about 1 year. Okay, so what we need to do is multiply the principal times the rate. But before we record this, let's convert the percent rate into a numerical value. That means move the decimal dot 2 places. So it's 0.04, that's the rate, times the principal x. So this expression tells us how much interest we'll receive from this account after a year. Let's do the same for the second account. The second account pays 6%, so it's 0.06, times the principal y that we put into this account. So this expression represents the interest that comes from the second account. Therefore, the total interest from both accounts is the sum of these two expressions. And what do we know here? In 1 year, these investments yielded $950 in simple interest. So that's our total interest. Therefore, this is equal to 950, and we have a beautiful equation, first equation that relates x and y. Now the second equation comes from the fact that x and y together totaling to $18,000, because we took this overall amount of money and split into two parts. Obviously, we can't assume that those parts are even. So that's why we use different letter for the amount of money put into the first account and different for the second account. However, altogether x plus y is our original $18,000. So that's how we set up this system of equations in investment problems. Okay, so now what's left to do is just to solve it. I like to get rid of decimals first. So what we can do, we can multiply the first equation by 100 and then rewrite our system of equations equivalently with no fractional coefficients anymore. So 100 times the first term is 4x plus 100 times the second term is 6y, and then it's 950 and 2 zeros because we multiplied by 100. Second equation we can rewrite as it is, or in the meantime we can solve for one of the variables. For example, if I solve for x, I can write x equals 18,000 minus y, and then solve this system of equations instead. So now I will use substitution. Instead of x in the first equation, I'm going to write this whole bracket in terms of y. So it will be 4 times bracket 18,000 minus y plus 6y equals 950 and 2 more zeros. The rest shouldn't be difficult, so why don't you finish this on your own and then come back to the video to check if the answer is the same. After distributing the 4, we end up with 72,000 minus 4y plus 6y equals 95,000. And then 6y minus 4y is 2y equals 95,000 minus 72,000 is 23,000. Finally, we divide by 2 and the y becomes $11,500. So that's the amount of money invested at 6%. Okay, let's go back to our substitution equation to find out what x is. That will be 18,000 minus 11,500, leaving us with 6,500. So 6,500 was invested at 4%. We are ready to give the answer. He invested 6,500 at 4% and 11,500 at 6%. Next very common type of problems is mixture or solution problems. Well, they both work the same way, except that mixture refers to solid items that are mixed and solution to the liquids. But the process of dealing with this type of problems is exactly the same. How many liters of a 15% acid solution and a 25% acid solution should be mixed to get 30 liters of an 18% acid solution? So let's introduce the variables. Let x be the volume of 15% solution in liters and y be the volume of 25% solution. We'll try to organize the data in a table like this. Percent times a volume equals the content. The content, that means what is dissolved in water. In this case, it's acid. Percent times a volume equals the amount of acid in the solution. And then we have two categories, two solutions that we're going to mix. 15% solution, 25% solution, and the mixture should be 18% solution. Well, so the first column is really easy to fill in. The 15% really means 0.15 as a number. 25% is 0.25. The mix should be of 18%, so it's 0.18. Now, the volume. 30 liters, that's the overall volume of the entire mixture. 30 liters goes here. How many of this and how many of that, we don't know, but that's why we introduced those variables. So we have x liters of 15% and y liters of 25%. Finally, the content. Well, the content can be calculated just by following the formula in the table. Percent times the volume. So this column times that column is the third column. So we have 0.15x, we have 0.25y, and we have 0.18 times 30. The two equations that we are searching for comes from common sense, comes from comparing the volume, because we are adding the volume from the first type of the solution and the second type of the solution, putting these two solutions to one and the same bucket and mixing it to obtain 30 liters. So indeed we are adding these two, and that's supposed to be equal to 30. Let's write it on the side. X plus y must be 30. We are comparing the volume. And the last column is comparing the content. The acid obtained from the 15% solution plus the acid obtained from the 25% solution is the overall acid in the mixture. So let's write it down. 0.15x plus 0.25y equals 0.18 times 30 is 5.4. Okay, so how do we solve it? Let's get rid of decimals as before. If I multiply this equation by 100, after rewriting the system, we'll have x plus y equals 30. That's the first equation I just copied. And the second equation will move all decimals 2 places to the right. So it's 15x plus 25y equals 540. To make it a little bit nicer, I could divide this second equation by 5 to lower down the coefficients, so let's rewrite it again. In the meantime, let's solve the first equation for y. So we have y equals 30 minus x in preparation for substitution. And the second equation, after dividing by 5, will have 3x plus 5y equals 108. Now I can replace y by 30 minus x in the second equation. So we'll get 3x plus 5 times a bracket 30 minus x equals 108. And then we have equation with one variable. Let's distribute the 5. We'll have 3x plus 150 minus 5x equals 108. 3x minus 5x is negative 2x. 108 minus 150 is negative 42. So after dividing by negative 2x would be equal to 21. So we already have the first variable. That's 21 liters of 15% solution. And now let's go back to the substitution equation to find out y. Therefore, y is equal 30 minus 21, which gives us 9 liters. So we need 9 liters of 25% solution and 21 liters of 15% solution. We are ready to give the formal answer. 21 liters of 15% solution and 9 liters of 25% solution should be mixed. The last type of problems, probably the most common type, is motion problems. Here we have one example. A train travels 600 miles in the same time that a truck travels 520 miles. Find the rate of each vehicle if the train's average rate is 8 miles per hour faster than that of the truck. So, first of all, we know it's a motion problem. We know we have two objects, train and a truck, moving. The first thing that comes to my mind when I read a motion problem is the formula rate times time equals distance. This is a formula that you absolutely must remember. Rate times time equals distance, a golden rule that will help you to solve any motion problem. Secondly, let's see what the question asks for. Find the rate of each vehicle. That means both rates, rate of the train and rate of the truck. Well, let's introduce some variables. Since both train and truck start from T, we can refer to those middle letters, A and U, to distinguish between them. So I would like to denote VU, the average rate of the truck. The subindex U suggests that I'm referring to truck. And similarly, let's denote V with subindex A, the average rate of the train. So A for train. Obviously, you could use any letters here, but V is a standard letter that indicates velocity. Then let's try to organize all the information about the train and the truck in a table that starts with our favorite formula, rate times time equals distance. So in the first row, I'm going to record everything that I know about the train, and in the second row, everything that I know about the truck. Okay, the rate for the train and truck is already established. Those are the unknowns. So V sub A is the rate of the train and V sub U is the rate of the truck. Now, the second column refers to time. What do we know about the time from the problem? A train travels 600 miles in the same time. So we know that the time for traveling 600 miles is the same as the time for traveling 520 miles by a truck. Okay, so whatever the expression will be in this box and in that box, these two expressions should be equal. Now, where the 600 and 520 will go? Since this is about miles, that's a distance. Distance that the train covers, so train and the distance, that's the box. And the distance that the truck will cover, 520, goes here. So how can we figure out the expression for time of the train? Well, let's follow the formula rate times time equals distance. Therefore, if we solve for time, the time would be the same as distance over rate. We divide by rate, right? So the distance column divide by the rate column. Therefore, in this box, I'm supposed to write 600 over VA, and in that box, 520 over VU. So one equation we already see here. It comes from comparison of times. Well, let's write it down. 600 over VA is the same as 520 over VU. But we have two variables, so we need another equation. What would it be? Well, let's read the second sentence. Find the rate of each vehicle if the train's average rate is 8 miles per hour faster than that of the truck. So the train's average rate is VA. And this is, so it's equal, 8 faster, that means 8 plus, than that of the truck, than the average rate of the truck. So average rate of the truck is VU. Okay, so we just translated words into the equation. Let's write it down here. VA equals, and I can start with VU first maybe, VU plus 8. Okay, so we've got our system of equations with two variables. However, notice that this could be done by using just one equation. Instead of introducing the average rate of the train, VA, we could write at once that this is VU plus 8. And I'm sure you've done similar questions before using just one variable, but since we are working with systems of equations, I introduced two variables. Okay, in order to solve this system, it's enough to substitute instead of VA, write VU plus 8 in the first equation. So we'll end up with 600 over VU plus 8 equals 520 over VU. And now to solve this equation, we could cross-multiply as it is, but I would suggest to load down the numerical values a bit. It's enough to knock off one of those zeros from each side. It's like dividing by 10. With not much effort, we would get a lot smaller numbers to work with. So now let's cross-multiply. 60 times VU, this times this, equals 52 times the bracket, VU plus 8. And then when we open the bracket, we get 60 VU equals 52 VU plus 8 times 52 is 416. Finally, when we subtract 52 VU on the other side, we have 8 VU equals 416. And after dividing by 8, the VU becomes 52. So the average rate of the truck is 52 miles per hour. And the last thing that we need to do is to calculate average rate of the train, VA. So VA equals VU, which is 52, plus 8, so it's altogether 60 miles per hour. Okay, so now we're ready to answer the question. The rate of the truck is 52 miles per hour, and the rate of the train is 60 miles per hour. Is that reasonable? Yes, it is, because if the train goes a bit faster than the truck, then it should cover longer distance than the truck. So that makes sense.